concepts. We have functions. These are things that actually do stuff. So this might be writing to a database or building an image on the fly, which is something that we're doing at Trove. So yeah, then we have events. Those are the things that trigger the functions. That might be like a HTTP request, or maybe when an image is uploaded, that will trigger. So a whole bunch of different things can be events that trigger functions. We have resources. Those are things like, for my setup, I have DynamoDB set up as a resource, or if you wanted to spin up a queuing service, you would use this for that as well. Then we have services, and these are the kind of core pieces or like an encapsulated piece of serverless tooling. So you might, a mature project will probably have a number of services that interconnect. Finally, we have plugins. That's an extension point. We're not going to talk about plugins tonight, though. Installation is about what you expect. So I'm going to make a folder here and go into that folder. That's where we'll do our work. There is a little bit more setup to actually get connected to AWS or Google Cloud. I'm not going to go through that. This talk, I'm going to be talking about AWS, just because it's what I have the most experience with. So when we're in our folder, we just call this serverless create. We pass it a template. So if you wanted to use a different sort of language like Python, you would start off with a different template. And then we're just going to set it in this path for business service. That's going to generate a YAML file like this. You can see we have just the name of the service and the provider, where it's hosted. But importantly, we have our functions down here. These are, the things that do stuff. Here we have the hello function, and so that is used as a reference elsewhere. But the handler here points towards handler.hello. So when you run that serverless command, it also generates this handler JavaScript file, and the exported function is hello. So that's what it points to. So just really quick, you run this deploy script. I'm not going to do it now because it's pretty quick, but it sometimes can be like 2 minutes, which is a lot of time for a 5-minute talk. So, but I will just invoke this function here. I ran the command right before, and you can see, sure enough, after deploying, we get our function. It just kind of works. It's pretty great. Cool demo. Thanks, Jim. Now I want to be able to trigger this from like a URL, not just by calling some command line function. So here's where events come in. Here I'm defining an HTTP event, and when I hit this route, hello/handler, it'll trigger the function. And we can see what that looks like right here. You can see I have a really ugly URL. You could set up mapping later on, but there is our route and our result. And mind you, like this setup, once you get connected to AWS, this really just takes a couple minutes to get to this point. So let's see what else. I wanted to show an example of adding a resource. They tend to be a little bit more involved. If you know anything about CloudFormation, you might recognize this config. But pretty much here I'm going to give some permissions to Dynamo, and then actually allocate this resource here, a Dynamo table. It has a user ID and ID, so pretty fancy. I don't have a running demo of that, but you can hit this database just by pulling in a library, DynamoDB, that's provided by AWS, and making a request. So these are the basic tools that you need to make a website, and it can really, or to make an application, and it can really happen very fast. I wanted to show this because I currently am using my side project. I'm not the only user, but I'm one of very few. Hold your breath. But you could think of this as one person's cost. So 18 cents a month for one person running on an app is pretty impressive, and it fits my budget for trying to start a company. So in conclusion, it's a really versatile tool. It gives you a lot of really powerful tools that can essentially make building a website, building an application go very, very fast. I've enjoyed using it, and I suggest you should try it out. That's about it. Any questions? Really quick?
Any resources for learning more about serverless?
Yeah, I mean the serverless website they have a really nice walkthrough. They'll get you set up from ground zero, and it works.
All right. Well, anything else for Jim? Awesome, cool, thanks.
Oh,
Our next talk here is maybe one that's a little bit strange for a JavaScript meetup. We're going to learn how not to write JavaScript. But I've been hearing a lot of hype about WebAssembly. I'm sure you guys have too. I'm kind of curious about what it is, what it can do, what its limitations are. So I was really excited when Guy said he'd come up here and give us a rundown on WebAssembly, teach us sort of how it works, how to write it, and whether we should be scared of it or not, I guess, right? All right, everyone give it a welcome to Guy.
Let me get wired up here. Good luck. Good luck. You'll need it. I think the only reason I actually need wired up is for the camera, right?
For your mic, yeah.
Yeah. As I touch this mic and make all kinds of noise, God, I don't need it for the internet's sake.
Are we good? Yeah. Let's stick some of that.
Below the beard if possible.
Below the beard, if you don't mind.
I'm not sure how that'll work.
All right.
There we go. Well, I think it's above. It's under the beard. Can you hear me okay though? Checkity, check, check, check. 1, 2, 1, 2. Okay. So good. I'm on a screen. That's totally not visible, so I'm going to change my preferences real quick before I get started. Go to color theme. We'll go to default light, so you can actually see what I'm doing. Blind. There we go. And then same thing there. And same thing there. That looks okay. And then, we're not going to use terminal that much. Okay. Let's get to the slides here. Make sure my little remote pointer thing is hooked up. Hang on. That's not how it's supposed to work. There we go. I got one of these new spotlight pointers. So like this cool, point at the screen, right? And then I can, it's magic. So, sorry, I got a new toy. It just came in the mail yesterday, and you guys are here to see me play with it for the first time. So I work for Data Robot. Next slide. So this talk is called What's Old is New Again? An Introduction to WebAssembly. WebAssembly is something I think is kind of cool because it's assembly language, but for the web. I mean, I guess you could guess that from the name. But I like low-level stuff. Some of my earliest code I wrote in the 80s was in assembly language, and so I kind of like it feels a little nostalgic going back to it. Now, how many here have done that kind of stuff back in the day? A handful of you? Okay. The assembly for WebAssembly actually looks nothing like that, but the concepts are all the same. So this is the slide where I introduce myself. Hi, my name is Guy Royse. I work for Data Robot. I'm a developer evangelist there, which basically means that my job is to come out to events like this and give you guys talks and mention that I work for Data Robot. And did I mention that I work for Data Robot? Can I do that joke one more time and it'd be funny? No. No. We've got a machine learning API, automated machine learning, so if you're curious about that, ask me about it. I'm not going to talk about it during this talk. That's where I work. If you're curious about it, come check me out. We got some swag over here too you guys can grab afterwards. And if you ask a really good question, you might get a Data Robot t-shirt. So, ooh, you too can have one of these, except blue. So I've been writing software for a long time, probably about 25 years. I know for some people that might not be a long time, but I guess for everyone a long time is always how long they've been doing a thing. But I've been writing software for about 25 years professionally. But back in the 80s, I was I did the Commodore VIC-20, the Commodore 64. We had these low-level processors and these things. And so I cut my teeth on that kind of stuff. And so this WebAssembly stuff, like I said earlier, kind of hits a soft little spot in my heart. So in case you were curious what WebAssembly is, it's 50% web, 50% assembly. How many SpongeBob fans do we have in here? Okay, I hope someone got this joke. It turns out WebAssembly is not 99% hot gas and 1% web in town. I mean, I've seen some really clever things done with CSS to make all kinds of really clever CSS hacks, but that sounds way worse than JavaScript. And so you can use any language you want on the web as long as it's JavaScript. And I know some of you are thinking, well, I could use, I could use Elm. I could use ES6 is a lot better. It is a lot better. I personally don't like the class syntax because it takes away my privates, and I liked using closures to do that instead. But to each his own. One big advantage of the class structure in JavaScript is that now we don't have every framework creating their own version of it. That's a plus. You could pick another language and transpile to JavaScript, and that's really easy to do. Just get these simple tools, use npm yarn, Bower, Webpack, Babel, Grunt, Gulp, LiveServer, React, whatever. Just pick a big pile of tools and make them work, all right? Yeah, it's kind of a pain. Now, there are a lot of skeleton apps kind of have this set up for you. Newer frameworks do make this easier. But at the end of the day, you're still transpiling into JavaScript. So even though you might be using a better programming language than JavaScript, you still have to know JavaScript because your errors are going to be in JavaScript. And the other thing that's going on here is that you still have this download, parse, execute phenomena happening. So you download that JavaScript file, and it might be minified and transpiled and as tight as it can be, but it's still going to be bigger than a binary. So you got to download this big file. I mean, we make them as small as we can, but there's a maximum compression. I mean, once you get down to I saw a joke a long time ago that said deletion is 100% file compression. Maybe that's what we should be doing. But you got to download that file, and then you've got to parse all those symbols in it so that you can actually run the interpreter against that code. You got to parse all that JavaScript file because it's an interpreted language. And then once you've parsed all the tokens out of it, then you start executing things. And this is a slower process. That's why interpreted languages are slower than compiled languages. It's intrinsic to their nature. And so that's another problem that we still don't solve. Even if we transpile our JavaScript, transpile to JavaScript, and even if we solve all these problems, we still have this fundamental problem. But what if you could compile JavaScript to some sort of binary format? That's what WebAssembly is. Then you would get rid of the compilation, the parsing step. The parsing step would happen ahead of time, and you spit out a binary format that's quick and easily read. You could choose any language to compile it from. So you could write C code and get code that you could run in the browser. You could write Rust code. You get code you could run in the browser. You could even code it in raw assembly language, which we're going to do tonight, and run it in the browser. I mean, that would solve all those problems, right? It'd solve the language problem. It'd solve, with JavaScript, it'd solve the choice of language problem. It would solve the compilation, the performance issues. It'd be a silver bullet. Where are we going out to drink after this, by the way? MASH? MASH, okay. Is it close? because I need a beer. So, but that would be a total silver bullet. That would solve all those problems. And that's what WebAssembly is. It's an attempt to solve all those problems. And it's version 1.0. So it's the first attempt. So it's not completely there. It's got holes. But it's something that you can work with. There are a lot of products out there that are compiling to WebAssembly. How many of you are .NET people? I'm sorry. No, just kidding. I just violated the code of conduct, didn't I? Heard of Blazor? Blazor's cool, right? It'll compile to WebAssembly. They took the .NET runtime and compiled it to WebAssembly, and so it's a Wasm file that you can use. I have not played with this personally. Ed Charbonneau's got a great talk on this that he's been doing. So I think he's recorded it. It's probably online. You should go check it out. But yeah, it solves all kinds of problems. So, but I thought it'd be worthwhile because, not everyone has a gray beard like I do and has actually done assembly language in their careers. Some of you may have had a token assembly language class in college. Some of you haven't looked at it at all. And so we're going to go all the way back to the basics, right? On a microprocessor, all this thing understands are ones and zeros. And it doesn't actually even understand ones and zeros. It really understands 5 volts and 0 volts, or 3.3 volts, depending on your architecture. And so it just takes in these strings of instructions that are just patterns of ones and zeros. And that's incredibly hard to read, right? And so it's easier to represent it as text. So on the left there, we have some assembly code. And on the right there, we have the assembly code in hex. And the blue column there is the address location in memory. So that'd be the very first one there would be, look at me use my new toy. The 0200 would be 200 hex, and then so on. That's just the address. And so this is a little easier to read for humans, but it's still not very good. And so someone came up with a great idea of assembly language. Assembly language is a bunch of instructions, a bunch of mnemonic codes that you can use that represent those hex values on the machine. And then you just assemble them. You don't compile them. You assemble them and say, OK, well, this one's a LDY. So that is A0. And we got a hard-coded value 00 there. And so that's loading the value 0 into the Y register on, in this case, a 6502 microprocessor. Yeah. This is actually the first assembly code I ever wrote. I used to think that it would, I remember writing code in high school on this circuit board, and it had a little 7-segment display. And this was the code that I wrote, one of them. And I remember writing one that would cause the 7-segment displays at the top to spell out a bad word. My teacher was so proud. Maybe it was related to fire truck, I'm not sure. But it turns out this is just a doubly nested loop. And so where I'm using the X and Y registers as places to store that. And then I got a couple labels there for the jump operators to jump to. And that's what this does. It's more readable, though, than it is before, but it's still not really very readable. However, some people strongly disagree with the idea even in assembly language. So this is von Neumann, and he was not a fan of assembly language. One of his students actually took time to build an assembler to make the task of assembling all these this code easier, and was running it. And von Neumann yelled at him and said that it was a waste of valuable scientific computing instrument, of a valuable scientific computing instrument to use it to do clerical work. So he viewed assembling code as clerical work, and thought everyone should just read. He could read like the bit codes coming across the line, but von Neumann's a genius. I'm not, right? I needed those symbols, and most people do, and obviously he was wrong, right? Incredibly smart, but in this particular narrow category, he didn't have a lot of vision. Had a lot of vision in other areas. this is the original code that I wrote. This is the same code we've been looking at. I wrote it down on, I assembled it by hand. I was doing that clerical work. And so I literally wrote the code on the left, right? And then I wrote down on paper all the opcodes to make it work. So this is the very first assembly code I ever wrote. I apparently did not write down the code that displayed bad words on the 7-segment display. But even that's kind of a pain to read, right? And so someone said, hey, why don't we write in an even higher level language? And so we got C here. And I put the curly braces on the next line to satisfy the .NET folks that are here. Because actually I did it so that we know it wasn't JavaScript. Because in JavaScript, you never want to do that. Because there's gotchas buried in there. Thank you, semicolon insertion. And but it's just a basic nested for loop. It calls a scan function. And so you could take that code, compile it, and that would generate that machine code from a higher level language. Way easier. This is the stuff we do all the time now. Actually, a lot of us aren't even doing that. We're just using languages that are so many levels above this that we're not even really aware that this happens. But how many of you guys have done C or C++ professionally? Okay, you know the pain. Pain is real. I remember one time I was on a project and this guy didn't know that he had to delete memory after he allocated it. That was fun. Another time I didn't initialize a pointer to be null, and so it just pointed to, whatever. And it would work fine in the debugger, but when I made a release build, it would fail. And whenever I'd run it through the debugger, it would run fine. I'd step through it and everything worked, and when it actually ran, when you looked at it, the problem went away. We always call those Heisenberg bugs. But so this is your basic C code. And then it runs on this wonderful 6502 microprocessor. Now, there's a little bit of a flaw with this model. So I write code, I compile, and I target the instruction set of a specific microprocessor. And now that code will only work on that specific microprocessor. And so if I want to run it on another microprocessor, I have to recompile it. So I have to compile binaries for all these different platforms. And that got to be a little bit of a pain as microprocessors got more and more sophisticated, but you wanted to preserve backwards compatibility. It's like, well, I could run this on the new Pentium processor, but then it won't be backwards compatible on the old 386s. I'm dating myself. And so I compile it to the lowest common denominator and can't take advantage of the features of that newer processor. Or I'd have to create separate binaries for every single processor out there. And so, because there are a lot of processors out there. And so someone struck on a great idea, and I first ran into this idea in the Java space. And that's the idea of a virtual machine. Not a virtual machine like VirtualBox, but a virtual machine as in a Java virtual machine or a common language runtime in .NET speak. I know this is not an original idea from them. It goes back further than that, but my introduction to this was with the Java virtual machine. And the idea here is that you create a virtual microprocessor that you compile to, and then it interprets the bytecode. And it's not as performant as a straight binary compilation, but it does, as they said back in the day, write once, run anywhere, in theory. Actually, I'd say overall Java's been pretty good about that. And so this actually, this is the software solution this is how you solve all software problems, right? Create another layer of abstraction. This is another layer of abstraction on top of the hardware. They got smarter later. One of the things I remember when .NET was brand new, one of the big innovations they did was they introduced the just-in-time compilation. And so what it would do is it would take that bytecode and say, okay, I can target that and make a compiled version when it's needed for exactly the microprocessor that is in this machine, as opposed to just a lowest common denominator processor. And so your first run's a little slow, but after that, it's actually faster than if you had just compiled it with C or C++. So very cool. It's a great idea. And this is how they work. I write my C code. I compile it to, well, in this case, this is Java code. You can tell it's Java code because it looks just like C. Actually, whoops. If you look right there, you'll see it says Cafe Babe in hex at the beginning of that binary. Every Java class file starts with those 4 bytes in hex. And so it's just fun fact. Someone was having a little bit of fun with it and was like, oh, yeah. So I think it's supposed to be Cafe Baby. But there's no Y, so they used an E. So you take that C code, or that Java code, you compile it to this bytecode, it runs on the virtual processor, and then the virtual processor delegates it to the actual processor, which was not a 6502. I don't think Java ever ran there, but it was the image I had. WebAssembly does exactly the same thing, except it's in the browser. So you write your C code over there, you compile it to bytecode, you hand it off to the WebAssembly virtual machine, and then the browser has one of those and it runs it. And the browser is then an executable that's running on your platform, and you got all those layers there. But it's the same exact concept. We've just swapped out the microprocessor with the browser. Make sense? Cool. So that's our quick refresher on how WebAssembly works. Here's a little bit more on how assembly works. Here's a little bit more detail. So if you're thinking about using WebAssembly in an application, how it fits into that browser environment. So you've got your basic. I keep hitting the wrong button on this remote. Over here, you've got your CSS, your HTML, right? Your DOM. Down below, you've got your JavaScript. And your JavaScript can manipulate that CSS and HTML. We've all done this a million times, right? It's CSS, HTML, JavaScript. It's that holy trinity of programming languages that let us build web apps. Wasm, the WebAssembly module, is just another file that's put up on the web server. So you got a .css file for your CSS, you got an .html file for your HTML, you got a .js file for your JavaScript, you got a .wasm file for your WebAssembly code. And it's a binary file, it's downloaded. And then the JavaScript can instantiate that object using fetch or any kind of, it goes and retrieves it using a REST-based, not REST-based, but an AJAX-y kind of call. And then can instantiate those modules. And then when it does that, it can hand in stuff for it to call back on you and you to call it. So these WASM modules have an imports and exports, importing functions from JavaScript that it can call, and exporting functions to JavaScript that JavaScript can call. You'll notice that there's no arrow between the WASM and the HTML, and that's very deliberate. The WebAssembly modules cannot talk to the DOM. So if you want to do DOM manipulation, you hand it functions, it imports them, and then those functions will do the DOM manipulation for you. And then that WASM then runs on that virtual processor. And so I mentioned it's hosted with all the other web content. So those WebAssembly modules is just WASM files. They're just sitting on a web server. They do need to have a content type of application./WASM, or it won't work, although Chrome seems to be more tolerant of that. And Firefox was a little pickier about it. So, and you instantiate these things from JavaScript. And here's some sample code at the bottom here on how to do that. If you look, you see we're doing, I'll use the cursor here. We're calling fetch. And we get the file name, that'd be the path to the WASM file. That gives us back a response. We turn that into an array buffer, which is, these are both asynchronous, so they're wrapped in promises. And then we can say WebAssembly.instantiate the bytes once we get the array buffer out of that. And that's also asynchronous. So then we actually get a WebAssembly module back, and then we can start doing things with that module. And here we can see actually doing things with that module. You look here, you got let x equals module.instance.exports.fizzbuzz, passing in a 15. Right down here. So every module has an instance. Every instance has an exports. We have a callback internal to the WebAssembly. It's going to call back into that function you passed in. WebAssembly does not support strings. I spent a day and a half Thursday and Friday adding strings to a Fizzbuzz module to put it out on, because I had to write So in Fizzbuzz, right? We're familiar with the Fizzbuzz problem. Everyone's familiar with Fizzbuzz. You return fizz if it's a multiple of 3. For a number, you return buzz if that number is a multiple of 5. If it's a multiple of both of them, you return Fizzbuzz. But if it's the number, you just return the number. And all of those are strings. And technically, the numbers aren't, but it either needs to be returning a string or not in assembly. And so I had to figure out how I wanted to encode my strings and then actually write an implementation of I2A in WebAssembly, which I will show you, but I'm not going to live code because it took a while. But right now, the easiest thing to work with are numbers, integers, signed or unsigned. You can also do floats, and it's got types for that. And if you want to pass around more complex data, like I did with the strings, there's this idea of a WebAssembly memory. And so in the imports, you can pass in a memory object. And that parameter, initial :10, that's how many pages that memory object should be. Each page is, I think, 64 kilobytes. So whatever that works out to be. And so this has 640K, which Bill Gates told me once is more than enough for any computer to use. We'll never need more than that, so this should be everything you'd possibly need from WebAssembly. But once you've done that, then you can see down there, let shared equals new UN8 array. That gets a byte array back of that shared memory, and then you can start accessing things in it. And if you want to, you can slice through it and run it through text processors using like a text decoder and get the UTF-8 out of it if you want. Yes, sir. I think so, yes. I think you could. Yeah, you could. You could totally memory leak. Because you can compile C to this. And that shared memory could totally leak. Yeah. Fun. What's old is new again? It's a great question. You get a T-shirt when we're done. There's also these globals you can pass in, and they're sort of like shared primitives that JavaScript can also access. So you could say, hey, here's an integer that JavaScript has created, and then you can share that globally between all the WebAssembly modules that you import that into. Let's see here. I've talked enough. Let's do a demo. Sound good? Yeah. Okay. Okay, so not that one. We'll start here. Okay. That is, let me go over here and do an ls, Python. Okay, so I'll show you what this is here. All this is doing the simple HTTP server trick. And it's also making sure that application.wasm is the content type. So I had to do a little bit of Python code to do this. But a lot of times you can get away with just doing Python -m http.server. And I swear I can type. There we go. And I think that'll work, actually. But we'll go ahead and do the audio's on. It's never on. Let's fix that. There we go. Start server. So we'll go back to the other way. There we go. And if I go to localhost 8000, we can see here we've got this Fizzbuzz thing, fizzing all the buzzes since 1972. So we can enter a value to be Fizzbuzz. So let's put in like 2, click Fizzbuzz. And I am in the wrong folder. It wasn't. Do I have it running in another? No. Yeah, what's listening on port 8000? That's really annoying. I told you, live demos, right? Okay, so am I in the right folder here? This is the right one. Let me just quit terminal. Bring it back up. What did you do today? I watched Guy Royse fumble and try and start a server. Code, talks, intro to WebAssembly, code, Python, simple, or it's Python-M. Yeah, that should be fine. And then go to the browser, which is around here somewhere. Localhost 8000. See, the problem is it's bringing up the wrong fit. There we go. It was cached. That was the problem. So, what I've got here is you can choose JavaScript, C, Rust, or WebAssembly text format. And so I've written Fizzbuzz 4 different ways. And so I wrote a basic JavaScript implementation which doesn't use WebAssembly. And so if I put in 1, you get a result of 1. I put in 3, you get a result of Fizz, et cetera, et cetera. So let's go look at the code for this. And that is it that one? I've got too many samples and it's confusing me. Here we go. So just a quick show of how this works. We've got an app.js. I used the vanilla JS for this. I didn't use any particular framework. And so we just are waiting for the document to load and getting our DOM elements here. And then we add an event listener for that button to be clicked. So nothing super fancy here. When that button is clicked, we looked at the radio buttons to pick the selected mechanism. And so select mechanism just goes to the radio button, gets the value. And so if I So if I say C WebAssembly, then it will load one Wasm file. If I do Rust WebAssembly, it'll load a different Wasm file. That's all it does. And then I fetch Fizzbuzz, passing in that mechanism. And then I say, hey, get the number out of the text box, call Fizzbuzz on Fizzbuzz, and display the results. Now, all these modules return -1 for Fizz, -2 for Buzz, and -3 for Fizzbuzz, because the whole returning strings is hard. So one of the things I do in here is when I display the results, is I translate that to Fizzbuzz and Fizzbuzz down in here. But the main thing here is that fetching. If I fetch the JavaScript Fizzbuzz, I just instantiate JS Fizzbuzz, which is a very uninspired bit of code. I mean, it's just a Fizzbuzz implementation. I'm not going to show it to you. If I look at the C, if I say C Fizzbuzz, I set my imports, because these things have a callback. It'll log to the console what the Fizzbuzz result was, and it will put it on the screen. And so we pass in that callback, and then we get C/Fizzbuzz Wasm. And if you see right here, on the left, there's those two modules. And same thing for Rust. We bring up the Rust one. Same thing for the Wabbit one. We bring in Fizzbuzz.wasm, and then once we've got it, you can see we invoke these things in exactly the same fashion because they have the same signatures, right? Yeah.
Can you compile JavaScript to WebAssembly?
I don't know, but that seems like a good idea, honestly. I mean, I don't mean that as ironically at all. I think it would be great if I could take my JavaScript code and compile it just for performance reasons, and for download speed and stuff like that. So that's a great question. I don't know the answer. Is it? Yeah, I'm not surprised, honestly.
It can end up going slower because it doesn't have as many hints, and WebAssembly engines are not as well developed as JavaScript engines. But it is a lot smaller in terms of file size.
Yeah, that sounds very believable. I don't know if that's true or not, but I'm going to choose to believe you because it sounds totally plausible. This is new stuff, right? So here's the C implementation I wrote for Fizzbuzz. Not terribly inspired. But the way I compiled my C++ code for this demo here was simply to go to this site here, which is in the links at the end of my slides. And literally, I can paste in the C++, hit compile. It will generate a bunch of Wasm file here. And then I can download it. And you see, I just downloaded test.wasm. So boom, it compiled it. And then I could shove that into here, which I've already done. So I'm not going to do that again. For compiling Rust, here's my Rust code. I am not a seasoned Rust developer at all. I mean, I just sort of Googled my way around to figure out how to do Rust, just to show that you could do Rust. Because Rust has got this mutability and ownership model that I haven't fully gotten my head around yet. And I haven't had a strong motivator to get my head around it because I've had other stuff to learn. Because you can only learn so many things, and Rust is not one of them that has been a heavy focus of mine. But the fact that it compiles to WebAssembly is pretty cool. And so I got a public function here of Fizzbuzz. It takes a 32-bit integer in, returns a 32-bit integer out. And we got a mutable result, and we're just doing modulus checks here. And then our callback into our JavaScript code is wrapped in an unsafe tag because it's external code. And to build that, I use this little shell script I wrote, and it's got all the information you need to know to get that going. You have to add this target, wasm32 unknown unknown. I've done that already, so we don't have to do that. And then here's all the options. And someone who knows Rust better than I could probably create this in some sort of better process than just putting every command on the command line for one file. But for demo purposes, this totally works. And then one of the things with Rust is the Wasm files it spits out are actually enormous. And so there's a Wasm GC extension which makes it less enormous, but still pretty large. And to show you what I mean here, I'll get to my go into the Rust code here. And if I do build.sh, and I do an ls, you can see Fizzbuzz big.wasm is 675K, which is ridiculous. When you run it through the dembiginator, it takes it down to about a third of that size, which quite frankly is still pretty ridiculous. I'm sure what's happening here is there's a whole bunch of libraries that are coming along with it that are just part of standard Rust that are required. But it does work. And so I will show both of those working. Yes, yes. So if I select C WebAssembly here and put in a 3, or let's put in a 5, and I hit Fizzbuzz, it totally blows up on me. And it says Fizzbuzz is not a function. Does Rust work? Rust works. So I probably need to take that Wasm file I downloaded and actually copy into there. And the WebAssembly text version, of course, should work as well. Let's put in 15. And I click it. It says Fizzbuzz. And you can see here in the console, the callback is executing and passing in that result. Okay, this is great. Could you show me the WebAssembly code? Yeah, I've been sort of dragging that out, haven't I? It can be Lispy, actually, but doesn't have to be. Okay, so here is the WAT file. I love that it's called a WAT file. I always think of, well, you guys, WAT, yeah. So this is my implementation of Fizzbuzz. So here you've got a module that you've defined, and it's using the parentheses for scoping. And I'm exporting a function called Fizzbuzz, and that func is referenced by this label here. I'm importing a function called callback, which is in a module called Fizzbuzz. And I'm going to name that $callback, and it takes a single integer.
Does it type check the JavaScript function that you pass into it to make sure that it will actually take in an integer?
I have gotten errors where I've done that wrong. I think if you don't pass in an argument, I think it complains. We'll find out. I think if you pass a float into it, though, I think JavaScript may coerce it. I'm not sure. I haven't tried that. I haven't done much with floats yet. Most of the work that I've been doing is just with integers. So here's our implementation. So func Fizzbuzz takes a parameter named n. It's a 32-bit integer. Returns a 32-bit integer. And it uses a stack-based mechanism for doing everything. So on line 7, we call get local. And we say $n. And what that does is it takes this inputted parameter right here and loads it onto the stack. And then I take a constant, a value 15, and I load that onto the stack. And so now our stack has, if I passed in 5, it's got 5 and 15 on the stack. And then I call isMultiple, which is another function I wrote down here at the bottom. And isMultiple takes a number, the n that we passed in. It takes a divisor and returns a result. And so we get the local and the divisor and push them onto the stack. We call remainder u, which will pop those two things off the stack, calculate the remainder unsigned, and push that onto the stack. And so now if we got 5 and 15, 5 divided by 15 is 0, remainder 5. So 5 is now on the stack. And then we call equals 0. And equals 0 reads the stack and says, is it 0? No. Then return 0 for false. Otherwise, return 1 for true. And so equals 0 then pops the stack, pushes something back onto it. The last thing on the stack is what's returned by the function. We're expecting a 32-bit integer, which is how Booleans are represented here. And so that's what you get. And then this guy, then the call comes back and pushes that onto the stack. Then we say if, and we push -3 onto the stack. We call the call back. So if pops the stack and says, is there a 0 there? Or a 1 there? Is this true? If it is, then it goes into here, and we're basically saying 15, that's Fizzbuzz. And so we push -3 onto the stack. We call our callback function. We push -3 onto the stack again, and we return. And then Fizzbuzz returns -3. In our case, we passed in 5, so we would get caught down here instead. But it's the same pattern repeated multiple times. And so you can nest these using parentheses to make the code more readable, and that's what we're going to do next. So I'm going to actually use Jasmine to test drive building one of these WebAssembly modules. So one other thing before let's just go ahead and get into it here. So I'm going to go ahead and close this one so I stop going to the wrong things. Shut down my Python server here. And we'll just leave it there for now. So this is a very simple, there's no spec here. I've wrote a little Wasm helper to load the WebAssembly module, and I've got a spec runner. So this is a very basic Jasmine project. And then I'm going to go ahead and close this guy here, and I'll bring him up later. And let's go into tilde /code/ live. I wish it didn't beep like that. Okay, so I'm going to do Python -m ht server. That brings up a new server on port 8000. And if I go here, go to localhost 8000, it'll say file not found, it'll give me a directory. Okay, so no specs found, which makes sense. Let's code a spec. So describe How am I doing on time, by the way? What's that mean? Okay, I got plenty of time. Okay, good. Okay, so how many of you are familiar with Jasmine? Most of you? Good. We'll do a let subject and before each done. No, wait. Function and then done. And I need to say call into I need to call load Wasm slash fizzbuzz.wasm dot, and that will return me the exports that I can use. So dot then we'll call this module. And then subject equals module. Dot then done. I've got one of these. You think I'd be used to this Mac keyboard by now? I got the new Mac keyboard that's like super flat. I think Apple is conditioning us to use a touch screen for a typewriter because they keep making their keyboards flatter and flatter and flatter. Okay, so this is going to load the Wasm file up at this path on the web server. It's going to, when it's done loading, it's going to assign it to the subject, and then it's going to call done so that the before each knows it can finish. And then we'll say it. That is not it. You're not helping out Visual Studio Code. It returns the passed in number. Did I spell function right there? If I make a typo, call it out. I mean, give me 3 seconds, but call it out. Okay, so subject dot fizzbuzz1 expect to be 1. No, 1. So that's what we expect to have. We're going to call Fizzbuzz, pass in a 1. We're going to expect to get that 1 back. Okay, so if I run my tests, they're going to fail with an error along the lines of Command-Shift-R. I got to put the script file in this HTML here. There we go. Now let's reload this guy. So it didn't give me the error I quite expected, but it gave me an error saying, oh yeah, file not found, 404 Fizzbuzz Wasm. That's what I expected. So let's create a new file called fizzbuzz.wat, and we'll get a module there. And then we want to do export Fizzbuzz func Fizzbuzz. I think that's all we need. And then we can say func Fizzbuzz, and it takes a param of num, and it returns a result of I32. That number is also of I32. Excuse me. And then we're just going to say const I32 const 1. So that should return a hard-coded 1, I hope. So I have this wonderful plugin for Visual Studio that I use for doing this, where there's save as WebAssembly binary file. So it's this plugin that just lets you save them, and that's what I use to compile my WebAssembly. You can use Wabbit as well from the command line. There's lots of other tools, and I have them all listed on a slide at the end. But this is, quite honestly, the quickest and easiest way to do it. And it'll even give you little error messages down here, which I didn't get one of, so that's a good sign. I got a Wasm file here, and so if you look at this Wasm file, it says I can't display that. Well, you can actually right-click on it and say Show WebAssembly. And this is what the WebAssembly it generated from the code I wrote was. So it's disassembled it. So you can actually look at a Wasm file, and you can see it doesn't really know like all my variable names necessarily. It knows some of them, but it doesn't necessarily know them all. But this should do something different. Hooray! Holy crap, I've never gotten an applause for the first problem in Fizzbuzz before. But it's actually, I mean, obviously this is a bit involved, right? Let's get it to do a little bit more. It returns other passed in numbers. So let's pass in a 2. And then we'll write that test. We'll run that, watch it fail. Expected 1 to be 2. That's exactly what it should do, right? And so let's look at fizzbuzz.wat here and say, okay, I'm doing i32 const I. Instead, what I want to do is get local %num. So instead of returning a hard-coded 1, I'll return what you hand me. And we'll save that as WebAssembly binary. Replace. Hooray! I'm 2 for 2. Now you're just pandering. Get rid of that helper there. Get rid of the spec runner. We don't need that. Okay, so it returns -1 for multiples of 3. Okay, expected 3 to be -1, exactly what we expect. So now we need to do something a little, we need an if statement here. So we can say if, let's do get local num, and then i32 const 3, i32 dot, is it EQ? I think it's EQ. We'll find out. Then if that's true, i32 const -1, return end, otherwise do this. So that should, we'll find out if that's the operator or not. Put on the stack, num, put in a constant of 3. Are they the same, yes or no? If they're the same, if it's a 3, return a -1. And we'll find out real quick. Did I see a hand? Sorry. No. Okay. The num is right here. So it's one of the parameters that's passed in. And you have to push it on the stack every single time you want to use it. Can I rename it? No. No, you can't actually. There is you can define locals using a syntax like this. You can say local, foo, i32 like that, and that'll define a local variable. And then you can call get local and set local on that as well, and it will allow you to gives you some storage in the function. What's that? You just need to make sure that anything you load onto the stack is popped off. So the stack needs to have one item at the end.
So it will yell at you if you have more than one item on the stack when you return?
Yeah.
So you can't do multiple returns?
I think you can do multiple returns, but I haven't.
Okay.
But I think that's only inside of WebAssembly. JavaScript's not going to know what to do with that. Right. Okay. But I haven't tried. You can, if the stack is empty and you say there is no result, then that's perfectly fine. That's a void. So you can, yeah.
So how big a value can you put on the stack? I mean, if you can only return one value.
There are, I'm using int32s. So it's a 32-bit integer, which is a fairly large number. I think there's an int64, but I'm not positive. I know you, but it's very C-like in this regard, right? And so it's just how big of an int does it support. If you want to return larger structures of data, what you have to do is you have to create a shared memory object that you pass between the objects, between Wasm modules and the JavaScript, and read it through there. So it's very. As I've been getting into this, I was writing this code to figure out I to A, and I'm like, okay, I got to figure out how many integers are here and stuff like this. And it reminded me of those early days of programming in C, where I was writing low-level algorithms all the time, and I didn't realize that I'd stopped doing that with newer languages. But it is very low-level like that. So if you want to return a string, you have to shove it into some shared memory structure and do that. If you want to return lots of data, you have to do those sorts of things.
Can those shared memory structures be mutated by the Wasm files and by the JavaScript?
Yes. Yes, they can. And all that implies, because that, of course, then opens up a whole world of everything, right?
Is it single-threaded then?
I don't believe it's multi-threaded. There's a talk I saw somewhere where they're talking about WebAssembly and threads, but I haven't watched it yet. But I'm not sure how that works. So they really haven't looked how threads work that much in Java. What's that?
Can't you just run them in web workers?
You probably could. Haven't tried. Let me see if this compiles here. It does. That's a good sign. And it passes. Hooray! Now, if let's say I made a mistake here. So we'll say equals X, which is totally not a thing. And I do save as WebAssembly binary. I get an error down here. Parse wat failed. It's an extension. So if we, well, actually it does. So like you'll notice when I put an X there, it changed color. And so it doesn't seem to be popping up like. Yeah, but there aren't. I mean, there aren't a. This is just more of a type indicator. You could also do this for 16-bit integers instead. I think there are prefixes for lots of different sizes. Yeah. The hard way. I don't know how to step through the code. Yeah. Here's how you debug it. Import JS log. And then you could then call console log. You could import a function which would call console log for you. So this syntax is a little. Well, let's go ahead. Let's do one more scenario here, and then I'll show you my super uber implementation for other multiples of 3. So pass in 6 here. Oops, did I? What did it do? Oh yeah, I didn't recompile after I broke it. What did I do? We'll just try doing it again because that always works. Could be. Expected 6 to be -1. That's the error we should be seeing. So here, instead of saying equals, what we want to do is say I32 dot remainder underscore u, and that will divide the number by 3, and then put the remainder on the stack, and then we'll say equals z. Is the remainder equal to 0? If so, then go into here. There we go. And then I'll just go ahead and I'm going to cheat on the TDD here. We'll return -2 for multiples of 5 and other multiples of 5. And then we'll return -3 for multiples of 15. Make that 30. And so we should get lots of failing tests now. What's that? All at once. And then in here, basically what I need to do is just, I don't always reuse code, but when I do, I copy and paste. -3, 5, -2. And I mean, this looks like a lot of copying and pasting, but it's because there's no way to get around this. There's like no way to make this reusable. I have to push those two values on the stack so that I can call it. And so it's a little chatty, or a little verbose.
You can't write a function that takes in those two values. And
Well, you do, but then you got to push them both on the stack to call the function. And so you don't get rid of those 2 lines of code that are pushing the value onto the stack. That was the first thing I tried to do, actually, and I'm like, oh, shit, this doesn't work. Okay, so they all pass. Hooray! So I wanted to finish this up because I wanted to show you there's actually a little bit of a lispier way to do this that makes the code a little more readable. And so instead of saying i32.remu after shoving 2 things on the stack, I can wrap these in parentheses and then do this. And that is arguably more and less readable. Right? And you can do the same thing with an if. If i32.equals-z, then wow, that is like the worst spelling of return ever. All right, now that's a little more familiar style code, and you could probably even like one-line this a little bit in this particular case. I don't think I like that though. So that's a little more readable. And if we, and then we can get rid of this. That's what I'm going to do next. Yes, they do. And if I wanted to create an is multiple function, I kind of showed that in the other example. I could just define a function here. It's worth noting that I don't have to export all the functions I define. So there actually is a concept of private functions. And so these almost feel a little object-y. I could see how someone could use these to implement an OO sort of model. So that's what we got so far. So hey, I live coded Fizzbuzz. It didn't die. I feel accomplished. I'll show you real quick here then the Fizzbuzz version I wrote that was the really hard way. Let's get to it here. I think that's under spikes. Nope, under samples. And this is out on GitHub. So if I do Python -m http.server, what's that? I know, shame on me, all right? And then I should have backgrounded this. There we go. And now we can look at the code as well. So this is very similar to that other Fizzbuzz, except it only uses WebAssembly. And it's actually returning strings. So if I put in 12 and hit Fizzbuzz, it'll say fizz, which the other one did, but I was doing it all in JavaScript. And here, I did it in Wasm. And so here's my app.js. And so upon loading the DOM, I create a WebAssembly memory object with a page size of 1, because I don't have a lot that I need to be there. I create a passive view, which is just a thing that interacts with the DOM. So if you call the getInput, it returns that as a number. If you call setResult, it calls this decode string function, passes in the memory object, and the result that was passed. And this is important because what decode string does, if we look down here, is it takes the memory, gets the buffer, and an offset. So it takes the offset. So the thing returned from the WebAssembly module is a number saying, in this big blob of memory, at location 17 is your string. It's a pointer. And then the way I encoded them was that first byte of that string is the length of the string, and then all the bytes of the string are after it. And so that's what this does. It takes the first one and says, that's the length, and then we slice out all the bytes, and then we run it through text decoder and decode that UTF-8 string to a JavaScript string and return it. And so that's actually what's happening with this set result to decode it to get the Fizzbuzz. So the fizz or the buzz or the Fizzbuzz or the number as a string is all coming from WebAssembly, which took me a day and a half. And then, so I've got multiple modules here. I have a math.wasm, which I put some helpful math functions into. I've got a strings.wasm, which is where the I2A exists to turn that integer into a string. And then those are both, so the math.wasm is injected into the strings.wasm, and then strings.wasm is used by view.wasm, because that's the thing that's going to put it on the screen. Model doesn't use it, but these guys can load up in parallel because they're not dependent on each other. And then when that's done, we load up the controller, which uses the model and view WASM files. So I've got this sort of dependency injection mess of code here between line 22 and 41. And then once I finally have my controller, I can do my binding and say, hey, when someone clicks the button, call the controller's WASM function on button clicked. And so this is a lot of plumbing code, but there's no logic in here other than like the parsing stuff, the plumbing stuff. I have this idea that you might have like a dependency injection framework for WASM, which we'll call it Spring WASM. I don't know. What's that? No. A file has one and only one module in it. No, it can't. It can only be imported things it's handed when it's instantiated. And so a lot of those things are things I want to do later. And this is version 1.0 of the spec, and so it doesn't support that yet. So if we look at the controller.wasm, it is terribly uninspired. Here's our exported onButton click function, and imports model and the two functions on the view. And so when you click it, we call getInput. That is passed into Fizzbuzz, and that is called into setResult. And that's all this guy does. He's really simple. The view brings string I2A, and it has the passive view, which is the JavaScript code that actually interacts with the DOM. It's got the memory object there, and it exports a getInput and setResults that are used by the controller. I have in my data structure here, there's this data tag where you can say, I've got this memory object, I can only have one of them. At location 0, put this string. So this is the only string you'll see in WebAssembly. And it's just turning it into bytes. And so this /04 is just an escape code for hex digit follows. Well, 1 byte of hex follows. And so that's a 4-character string. This is a 4-character string, and this is an 8-character string. So that's what that means. Get input just calls the HTML input function. And then set result interacts with the model. And the model returns -1, -2, or -3 for the fit like we were doing before. But now we can say if the result that I'm handed is -1, then call set to fizz. If it's -2, you notice I used an else here. Call set to buzz. Otherwise, call set to Fizzbuzz. Otherwise, call set to number. And down here, set to Fizzbuzz just says return location 0. So we're handing it a number, which is an offset in that memory structure. Here it's location 5. Here it's location 10. But set to number actually has to take the number, call integer to alpha, pass in that number, and pass in a location to put it in that memory. And then it passes that location. So if we look at strings.wat, we can see that I wrote a lot of code, which I'm not going to go through it in detail, but basically involved, hey, keep dividing this thing by 10, and figure out if it's a digit, and then shoving that ASCII code into memory at the next location. And so I keep dividing it by 10 until to count how many digits there are, and then I start at the right and move forward, or move back to actually store that. And so that's how it works. And yeah, it was actually quite a bit of code. And all this does, here's my digit to UTF-8. Add 48 to the number you handed me, right? Because 48 is 0 in ASCII and in UTF-8. And then I had to write a little math helper here. And so I wrote an increment, a decrement, a power function, because there's no function to do exponents natively in WebAssembly, and a function to count the digits in a number, decimal digits, not binary digits. And this is all up on GitHub, my GitHub account. So I learned a lot writing this, actually. I learned a ton. So that's pretty much the demo. Any questions so far? Yeah.
Should I start rewriting all my JavaScript in WebAssembly and shipping it to production?
Absolutely. I think for certain things it might be worthwhile to play with. Personally, I'm a little conservative when it comes to the tools I'll use for writing production code, and so I probably wouldn't use this for production code yet. I'd probably, my gut tells me wait another 6 months, which is like an eternity in web years, I guess. But yeah, we could be using DuJour.js by then. So yeah.
Do you know what the history is for the design of the WebAssembly VM? It seems really weird that they're like half-stack machine, but they also have locals and functions.
I don't know the history of that at all. And I haven't really compared it to other virtual machines. This is the first time I've ever, I've used Java for a lot of years, but I've never looked at how the JVM works or what the bytecode actually looks like. I do know that this particular language mimics the bytecode directly. So that int32.const shoves a hex code at a particular location. But what inspired it, I'm not exactly sure. I know there are a lot of tools here that you can use to compile it. In fact, there's an LLVM bitcode to WebAssembly compiler, which is kind of cool. So I saw some other hands, though. Yeah?
The browsers operate with the security sandbox. So if in your C or Rust or whatever source language you're using, if you attempted to write to the file system, or
it just wouldn't work.
What part wouldn't work? It wouldn't compile or wouldn't execute?
I'm not honestly sure. I didn't try. I know that that's not supported because it's in the same browser sandbox as everything else. And it's the same reason you can't write plain old. You can't take like Node stuff that writes to the file system and try and do that. Doesn't work. So I don't know what would happen. My guess is that the compilation would fail. It would say I can't generate bytecode for that, but I don't know that. I haven't tried it. Yeah.
Do you know if there's an isolated heap, or are you just limited to that the number of pages that you're passing into a module when you?
You've got the stack. You've got your local variables, and you've got that memory page. And that's there's also a global, which is kind of like that shared memory page, but they're just global variables that can be exported to JavaScript and passed between modules. But there's no proper heap.
If I'm doing stuff right in the WebAssembly, can I do allocations to heap space that I don't need to pass back to the JavaScript necessarily, but just hang on to for a minute?
With the that would happen in that memory module, right? Okay. That is in effect the heap, and it just grows every single time. If you need it to be bigger, it will grow automatically. Right. So it allocates an initial 64K, and then every time you expand that, it'll just allocate another 64K. I don't think there's a way to have it deallocate that, but it's an edge I haven't explored yet. Huh?
PHP, you only allocate memory and then you die.
I saw other hands down here. Yeah.
I was just wondering what the state of the spec is. What's coming next, and.
That's a good question. The 1.0 spec just came out a couple months ago, so it's fairly new. It might have been 3 or 4 months. I'm not exactly sure. And honestly, the text format's not terribly well documented from an end user point of view. It's got specifications so that if you were writing a compiler or a disassembler, it would help you. But I had to poke and prod it to say, I think this is how this thing works, but I'm not sure. And so I had to try a couple of permutations that made sense to figure out and try and compile and see if it would work or not, because the spec's kind of opaque. So it was. I would not recommend writing any production code in actual WebAssembly text format, because that's hard, right? But I don't think I answered your question or not.
Well, it tells me the state of it right now.
Okay. Yeah.
So it seems like to get this to work on a language, the language has to have some kind of translation to like the JVM or whatever. Virtual machine. Do you know, are those runtimes or compilers, whatever you want to call it, are those made by like the language community, like core team themselves usually, or?
No, they're not actually. They're made by all kinds of people who are supporting different languages. Okay. So the Rust team, Rust was actually one of the first ones to adopt this, and so Rust out of the box supports this. There's a little bit you got to do, but it's something that Rust just supports. Okay. Whereas like on .NET, they're kind of guiding you towards using Blazor. And there's actually a whole, whoops, if I can get this.
Like the Python one, I don't think that's built in, right? So that would have been.
Yeah. One of the links here is a page here of all these languages that support WebAssembly and links to tools that do it. So there's quite a few here. These ones aren't so great, I guess. But like there was a Java one where it used, it would take class files and just convert them into WebAssembly. It'd take Java bytecode and convert it into WebAssembly bytecode, which I thought was kind of neat. Stuff like that. So there's lots of tools out there, and they're made by all kinds of people. So if you wanted to make your own language, you could totally implement the spec. You should go out and do that. Yeah, back there.
Browsers support WebAssembly?
All of them. I have successfully run this scenario, this code here, on Safari, Firefox, and Chrome. Edge says it supports it, but I have a Mac, so I'm going to trust that it does. And it also works on the mobile browsers as well. So it's actually got very broad support. No. And get out. Yeah. Any other questions? Yeah.
I assume this would work server side and browser.
This is browser only.
Browser only.
Yeah.
Why can't you call it?
From
why can't you call it with say Node?
I don't know that anyone's built a WebAssembly interpreter for Node. I suppose you could. It's bytecode. You could make something to run it. But
Fastly is working on that right now.
Oh, are they?
If you go to the Duo Tech Talks on YouTube, there was a tech talk with someone from Fastly talking about using WebAssembly on the server specifically because of the security and sandboxing it has. But it's still very much an experimental thing. You can take V8 and try and get WebAssembly running in it on the server. But right now, you got to be real comfortable with C++ to do it.
How about support for post message?
For posting messages?
Yeah.
It doesn't have access to any of the browser extensions. All it does is expose functions that can basically operate on numbers. That's pretty much what WebAssembly does at this point. That's why, for example, I had to write DOM manipulation functions and call into them. If I wanted to do like an HTTP post from WebAssembly, I would have to write a shim function that I would import into that WebAssembly module from JavaScript.
So
Yeah.
That was kind of my question, actually. So there's no browser API access even for things that aren't DOM manipulation unless you pass in a callback.
Correct.
Yeah.
Yeah. A lot of questions. That's always good. So I feel like I've gone a little bit long. I apologize. My talk is out here on GitHub. You can go check out the code there as well that was in this talk. The Wasm Fizzbuzz that I implemented that actually turns strings is not at this repository. It's at a repository called Wasm-Fizzbuzz on my GitHub account as well. So it's out there. I just don't have it in. I didn't get my slides updated to show that in there. And we did that already. And that's me. Oh, and did I mention I work for Data Robot? Thank you.
That was awesome. Thank you.
Thanks.
Now, have you thought of a question that you can ask the audience to see who is paying attention? This will be for a 1-year subscription to a JetBrains license.
No, I haven't.
Well, all you think about, let me explain this. The way this works is if you shout it out, you're disqualified. You got to raise your hand, and I'll call on you. Whoever I see raises their hand the fastest. Was that enough time?
Sure.
Okay. All right. I'm watching.
Okay. So, how big is the page size for a WebAssembly module?
Damn.
Okay.
64K.
64K.
All right.
Is that kilobytes
Kilobytes.
or kilobytes? Kilobytes.
Whatever you said.
It's fine. You get it. You can get a T-shirt. So, you and you both get shirts, right?
Okay, cool. All right, well, everybody, thank you for coming out. Yeah, come up and get some swag, I guess, right?
Yeah.
And we'll be heading over to MASH just in a little bit. So, thanks a lot, everybody.
And I do have a few shirts, so but.